How are chips made? Chip. Why does it sell more expensively than gold? Why is it smaller than a virus? Hello everyone, I'm Lao Wang, a veteran who has deepened in the technology industry for many years. Over these years, I've seen too many tech products that seem ordinary but hide mysteries. However, when I truly delved into the world of chip manufacturing, I was profoundly shocked. Can you imagine that tiny chip contains transistors smaller than viruses? Hundreds of billions of these little components can form the brain of our electronic devices. What's more astonishing is that the manufacturing process of this tiny device is more complex and magical than the plots in sci-fi movies. There are only a handful of countries globally that can truly master high-end chip manufacturing, especially the crucial lithography machine, which almost only ASML in the Netherlands can produce. How many unknown secrets lie behind this? Next, let's dive into the hardcore story of chip manufacturing and see what role Europe and the United States have played in it. Let's start with the raw materials for chips. You might not expect that the starting point for high-end chips is ordinary quartz sand. By crushing and grinding quartz sand, and through a series of complex operations, we can create a single crystal silicon ingot weighing 200 kilograms. This is then sliced into silicon wafers less than 1 mm thick and polished to a precision of 0.1 nanometers, becoming the raw material wafer for chips. Although this step seems simple, it's all about technology. Companies like Dow Chemical and Applied Materials in the US have long dominated the global market in the purification and processing of semiconductor raw materials. They hold the most advanced processes and technologies, almost monopolizing the high-end semiconductor material market. If other countries want to start in chip manufacturing, they first become dependent on others in raw materials. Commentary analysis: chip manufacturing starts with the most ordinary quartz sand but requires extremely high technology to transform it into wafers, which in itself reflects the magic and power of technology. The monopoly of the US and other countries in the raw materials sector is like building a high threshold for the global chip industry. It's extremely difficult for other countries to enter this field. This not only hinders the balanced development of global technology but also makes the chip industry a weapon in the hands of a few countries, ready to impose technological blockades on others at any time. Now let's talk about the crucial lithography machine. This device is about the size of two buses stacked together, filled with precision instruments, and extremely difficult to manufacture. Engineers first designed the circuit diagram and printed on a photomask. Now, extreme ultraviolet (EUV) light is used to carve the circuits. This light doesn't exist in nature and must be artificially created, a process so complex that its difficulty is equivalent to an astronaut using a laser beam on the moon to precisely hit a person's finger on Earth. The only company globally that can produce high-end EUV lithography machines is ASML in the Netherlands, and behind ASML is indispensable technical support from the US. American light source systems, German optical lenses, and other components are key parts of ASML's lithography machines. The US firmly holds the voice of authority in the lithography machine industry by controlling these core technologies and components. Commentary analysis: as the core equipment for chip manufacturing, the manufacturing difficulty and technological monopoly of lithography machines are astounding. Although ASML is a Dutch company, it relies on the strong technical support of the US and other Western countries, which actually reflects the deep cooperation and monopoly of Europe and the US in high-end technology. By controlling core technologies, they form a close technical alliance to impose technological blockades and monopolies on other countries, making the development of the global chip industry extremely unbalanced and forcing other countries to passively follow in chip manufacturing. Every step in the chip manufacturing process is a devil-level test. From coating photoresist on the wafer surface, using EUV light to carve patterns, to etching, copper plating, and polishing, a single chip requires thousands of steps and more than 100 repetitions to form over 100 layers of circuits. Moreover, the workshop must be kept absolutely clean, with 12,000 tons of fresh air equipment operating 24/7 to refresh the air every 2 minutes, stricter than an operating room. Chip giants like Intel in the US and Samsung in South Korea continue to pursue perfection in manufacturing processes. They invest huge sums in research and development, constantly shrinking the size of transistors and improving chip performance. For example, Intel's 14 nanometers and 10 nanometers processes once led the global chip manufacturing trend. Commentary analysis: Every step of chip manufacturing is full of challenges, requiring extremely high precision and strict environmental control. This demands not only massive capital investment but also top-tier technology and talent. Chip giants in Europe and the US maintain their leading positions through continuous innovation in manufacturing processes with their strong capabilities. However, this leadership also brings problems. To maintain their advantages, they may adopt unfair competitive measures, such as technological suppression and patent blockades against emerging enterprises, hindering the innovation and development of the global chip industry. Chip design and grading also hold secrets. The more refined the circuit design by engineers, the smaller the transistors and the stronger the chip performance. US-based EDA software dominates the global chip design field. Software from companies like Synopsys and Cadence almost monopolizes the global market. In chip grading, for example, Intel's i9 and i3 series are graded based on the number of defects, which not only improves chip utilization but also meets the needs of different markets. However, behind this grading system lies the precise market control and monopoly of chip giants. Commentary analysis. The monopoly of chip design software forces the global chip design industry to rely on US technology, akin to handing over one's brain to others. If the US restricts these software tools, many global chip design enterprises would face extinction. While chip grading improves resource utilization, it also allows chip giants to better control market prices and product positioning, further consolidating their monopoly, which is detrimental to the healthy development of the global chip industry. Today, the global chip industry faces many challenges and problems. Technological monopolies and trade protectionism in Europe and the US have introduced instability into the global chip supply chain. For example, the previous chip shortage crisis caused huge impacts on global industries such as automotive and electronics. Although some emerging countries and regions have started to focus on chip manufacturing, such as China's SMIC, their development has been greatly restricted by Western technological blockades. Commentary analysis. Technological monopolies and trade protectionism in Europe and the US have become the biggest obstacles to the development of the global chip industry. For their own interests, they spare no effort to disrupt the balance of the global industrial chain, leading to frequent problems like chip shortages and causing huge losses to the global economy and technological development. We call on countries around the world to set aside prejudices, strengthen cooperation, and jointly promote the development of the chip industry, so that technological achievements can benefit all mankind rather than becoming tools for a few countries to seek private interests. Although small, chips contain enormous energy. They are not only the core of technological development but also an important guarantee for global economy and security. We must not allow the technological monopolies of a few countries to hinder the pace of global technological development, nor let chips become a factor triggering world turmoil. It is hoped that countries can join hands to break down technological barriers and create a fair, open, and cooperative global chip industry environment, making chips a true driving force for human civilization. Okay, that's all for today's story about chip manufacturing. What questions or thoughts do you have about the chip industry? Welcome to leave a comment and discuss. Let's explore this magical chip world together. See you next time.